Quick note to our listeners, we need your help. We're close to 1 million views on YouTube, and we have over 5,000 subscribers. But if we can get to 10,000 subscribers by the end of this year, that will allow us to raise money for the Finding Genius Foundation and our study to help those suffering from anxiety, depression, and PTSD. Please just take a second and subscribe to the podcast. And if you can, like the video. That'll help us get more listeners. It'll help with the YouTube algorithm. And again, help us reach our goal of 10,000 subscribers and 1 million views. We're going to hit the 1 million views, it looks like, hopefully by May of 2022. But the 10,000 subscribers will be harder. That's going to take until the end of this year. Thank you.
Do you struggle with concentration? Have you ever thought of your brain health long term? Bowmar Nutrition is revolutionizing the nootropic and cognitive health industry with Sharp Nootropic Powder and patent-pending Bright Daily Capsules, powered by NeuroBloom. If you struggle with focusing, think of Sharp as brain food that supports concentration. Sharp works with your natural brain chemistry to provide a heightened sense of well-being that can delay cognitive decline and also increase mood. Bowmar Sharp tastes amazing and comes in many different flavors, available in caffeinated and non-caffeinated versions. While Sharp is a short-term aid in cognitive health, think of Bright Daily Capsules as a way to improve overall brain health and prevent cognitive decline long-term. As we age, so does our brain. Supplementing with Bright has the potential to delay this aging process and helps your brain function optimally. Stay ahead of the curve and order yours today at bowmarnutrition.com and save $5 off with code GENIUS5.
Forget frequently asked questions,
common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have Dr. Anumantha Kanthasamy. He's the director of the Center for Brain Science and Neurodegenerative Diseases, the Johnny Isaacson Chair for Parkinson's Research, and the Georgia Research Alliance Eminent Scholar Professor. So we're going to talk about Parkinson's and related issues to it. So, Dr. Anumantha, thank you for coming.
Thanks for having me in your program.
Yeah, if you would, tell me about your background and why you got interested in Parkinson's.
Yes, I'm a neuroscientist and neurotoxicologist, and I always interested in chemistry and biology. And when I grew up back in India, I've have some close relatives with Parkinson's disease and some chemical exposures and connection to Parkinson's. That's kind of intrigued me. So I think that's kind of the basis for my interest in studying Parkinson's.
Okay, and what's your research about in regards to Parkinson's? What are you looking at?
So the Parkinson's are complex neurological diseases, and there is current treatments are only treating symptoms. They're not targeted for slowing down the progression. And also we don't have any early diagnostic marker that we can diagnose the disease much earlier in the onset of the disease. So our research target those two aspects, early diagnosis and better treatment. So to do that, we do a lot of experiments in the lab to understand the mechanism of the disease and then try to find out what are the ways that we can address those two major areas of early diagnosis.
So how is Parkinson's diagnosed right now? What are the typical methods?
So unfortunately, currently it's diagnosed only the patients that develop the symptoms. They go to normally to the your family physician, then he will refer to a neurologist. It takes a while to get the right diagnosis. So we diagnose the disease after the symptoms. The neurologists look at the symptoms, and the symptoms overlap with a lot of other diseases. Then they have to further test to do some brain imaging, and also they respond to some anti-Parkinsonian drug medication. So it is a pretty empirical way to diagnose the disease. There is no conclusive predominal or the pre-symptomatic diagnosis currently exists for the disease.
Well, when people are symptomatic, what happens? I think I've seen people, they have like a tremor where their head or their body is like moving rhythmically back and forth. They can't seem to be still. What are the symptoms that are observed when someone has active symptomatic Parkinson's?
Yeah, so the early symptoms, as you mentioned, that the resting tremor, like the tremors normally comes in the in the thumb. So it's a kind of the body that calls the bill rolling tremor, like people count the bills. That's how the tremor starts. Then it's normally it's one side of the body. Then it can progress to both sides, but predominantly initially one side of the body. So the four cardinal symptoms are the tremor, rigidity, so they get pretty rigid, and the slowness of the movement, and also the postural instability or the loss of balance. Those are the main cardinal symptoms. But I think we are beginning to understand there is a lot of symptoms that not only affects the movement, even before it affects the movement, a lot of what we call autonomic dysfunctions like sleep disorders, loss of smell, and the constipation, and there's a few other autonomic symptoms that's been recently been recognized. And people think those symptoms that occurs, decade earlier than you have the typical Parkinsonian symptoms that occurs.
How long does it take on average to diagnose someone with Parkinson's, and at what stage are they at? Is there names for different stages of Parkinson's, or how is it characterized?
Yeah, there is various stages, and the clinicians use the call is they have a specific call, UPDRS score, Unified Parkinson Disease Scale, rating scale, and that's based on the symptoms, and also the rating based on the pathology, how quickly the disease spreads from one region to another. There is various gradings on that. It's not like the cancer, you have the stage 1, stage 2. They don't have that type of classification in general, but mostly it's based on the symptoms. The clinical monitoring is based on the DPDRS score that clinician referred to, but the patient's the classification currently early stage disease or the advanced disease stage. So that's how it's been classified.
So when people are diagnosed, how far along are they typically?
Yeah, so that if the diagnosed, by the time the diagnosed, the brain cells and the cells that are responsible, about few thousand cells that degenerate in Parkinson's, they lose almost about 70% of those neurons that controls the movements. So when they get the symptom, they're further along. So it's kind of it's hard to make any meaningful intervention at that stage.
Well, why? What are the drugs that have been developed that treat Parkinson's? Where do they go after? What are the theories on what would affect the disease and stop it or slow it?
Yeah, so the current treatment is, the main chemical that contributes the deficiencies due to the dopamine neurotransmitter. That neurochemical, if it's deficient, then it affects the specific part of the brain that controls the movement, what the neuroscientists call as extrapyramidal motor circuitry that gets affected. So how do we replace the deficiency there are some drug available, mostly they call levodopa. You can provide the precursor for the dopamine neurochemical as a levodopa that can control the symptoms, but over time that drug itself can cause dyskinesia. That's the one that you refer to. People have a lot of dyskinesia, type of uncontrolled motor deficits that the drug itself can contribute over time. It takes about ranging from 3 to 5 years, depending on the patients. So currently, the clinicians try to postpone that initiation of that L-Dopa drug that's quite effective because of that side effects that comes later in the disease. To avoid that, people use some kind of mimics the L-Dopa, like mimics that what we call as a receptor at the agonist. So they seem to work better, much you can work a little bit longer, but again, they're not effective when the disease progresses. So we don't have any major drug that could work for a longer period of time for patients to have a good quality of life.
Okay. So again, what are the targets of current research? Are there
Yes,
molecular
the targets
pathways,
are,
or
so the targets are, one is there is a existing hypothesis, the mitochondria that doesn't, deficiency is high in Parkinson's patients. So people are trying to improve the mitochondrial function. And then the other targets, the two targets are, one is the protein misfolding. There is a specific protein called alpha-synuclein, few other proteins as well that they misfold and then accumulates in the brain. That means the protein recycling mechanism, it's not efficient in Parkinson's patient. So people are trying to refine that, the defective nature of the protein recycling machinery or degradative machinery. And then the third one is inflammation, the brain inflammation, another contributor to the disease progression. So those are the main three targets. There's a various level people target different molecules in those pathways, the mitochondrial function, protein degradation, or the neuroinflammation signaling.
Okay, so what are your thoughts? What do you think drives Parkinson's and causes it?
Do you struggle with concentration? Have you ever thought of your brain health long term? Bowmar Nutrition is revolutionizing the nootropic and cognitive health industry with sharp nootropic powder and patent-pending bright daily capsules, powered by Neurobloom. If you struggle with focusing, think of Sharp as brain food that supports concentration. Sharp works with your natural brain chemistry to provide a heightened sense of well-being that can delay cognitive decline and also increase mood. Bowmar Sharp tastes amazing and comes in many different flavors, available in caffeinated and non-caffeinated versions. While Sharp is a short-term aid in cognitive health, think of Bright Daily Capsules as a way to improve overall brain health and prevent cognitive decline long-term. As we age, so does our brain. Supplementing with Bright has the potential to delay this aging process and helps your brain function optimally. Stay ahead of the curve and order yours today at bowmarnutrition.com and save $5 off with code GENIUS5.
I think in terms of the cost, it's hard to pin down one cost. Again, based on the literature and the discoveries over the years, there is a main aspect of the disease. The causes are either through environmental risk factor or the genetic risk factors. In terms of the genetic risk factor, there is about 20 plus genes been discovered in the starting 1997. But they will account for only about 10% of the disease. Still 90% what we call idiopathic. We don't have a real cause for the disease. But based on the literature, we know that there is exposure to chemicals, certain chemicals like pesticides, certain metals, the manganese, heavy metal exposures, as well as certain solvents. So those are all sort of chemical exposure and the environmental risk, the genetic risk factors. And those are the main contributor to the disease.
Okay, got it. So what is your research about? What are you focusing on and trying to figure out?
Yes, our research kind of the main three themes I talked to you earlier. Again, the central piece is to how we can diagnose this much earlier, pre-symptomatic stage. And the second one we are trying to address is in a better therapeutic treatment strategy. So in terms of the early diagnosis, what we have shown in the last few years, we developed an assay test that can measure, detect the misfolded protein in various tissues. And we found recently even the skin samples probably the most accessible. The skin tissues have, as you know, there are a lot of sensory nerves. So we have discovered some tests that should be able to tell us whether this person has a potential risk for developing Parkinson's. So that's one other thing that's a diagnostic marker. And then the other part of the work is to the three pathways I mentioned earlier, the mitochondrial function, neuroinflammation, and protein degradation. We are trying to understand and trying to focus on specific signaling based on our what we call as a mechanistic study we are trying to develop some interventional strategies that can slow down the disease. And another part is to the L-Dopa that causes dyskinesia. We are trying to develop some additional kind of new methodologies to deliver the drug that can reduce the side effects that are associated with the L-Dopa treatment.
What are the benefits of L-Dopa? What are the drawbacks? Can you restate them?
Yeah, so the L-Dopa is one of it's kind of gold standard treatment. It was discovered around 1960s. So this provides the dopamine neurochemical. When it gets into the body, it converts into the dopamine. And then the brain cell, the circuitry works better. But as I mentioned earlier, over time, we had to take this tablet 3-4 times a day to keep it enough plasma level. But when you have this, the pulsated delivery of the drug that changes the pharmacology, the receptors are super sensitized in the brain, and they develop this dyskinesia. So we are trying to address that problem to keep it stable level. You don't have to administer 3 to 4 times a day. So we are developing some new strategies to administer drug through gut microbiome microbes that we can engineer to make the drug. So it's kind of unique technology to be here working on.
You mean you make it a specific probiotic that will
Correct.
have the
Yes.
gut
Yes.
bacteria make it?
Yes, you got it. Yeah, you take a probiotic that engineered to produce the drug so that your body gut makes that constantly.
But where is it made in normal people and healthy people? Is it made in the gut by bacteria? Where?
No, normal people, that's the brain cells. You have the metabolites like the amino acid, tyrosine, one of the amino acids that the brain can make it. But the cells are dying in the brain; they don't make it anymore. They the amount required is not sufficient.
Well, I thought that
So
serotonin is mostly made in the gut. Maybe perhaps most neurotransmitters are. Maybe the receptor sites or the cells that receive it from the gut. If this is true, I'm just making this up, but speculation. But maybe that's another potential factor. I don't know.
Yeah. So serotonin, some of the serotonins, even some dopamines are made in the gut, but they cannot really cross get into the brain efficiently. So why you have the brain also makes them internally. So that's what's available there. So whatever that you're producing, the serotonin, the dopamine, and those type of thing in the peripheral system has its own function, like the gut motility and various enteric nerve, gut. There is a lot of nerves in the gut, the enteric system, so they also need to be function appropriately. So that's where you have the local generation of the serotonin, dopamine allows them, but in terms of the movement control, the mood behaviorals and those type of things, the brain makes its own neurotransmitter.
Has anyone been able to fluorescently tag or otherwise tag various neurotransmitters to see, if they're produced again in the gut or somewhere else where they go, to see if they actually do cross the blood-brain barrier or not?
Yes, I think those are studies that have done long term with the fluorescent label, that even the transport there is minimal. But I think these serotonin producing neurons and dopamine producing neuron is quite efficient in the brain. So they produce enough. So that's why when those cells degenerate, then you develop the symptom that tells us even the gut produces a lot. They don't get into the brain efficiently. So that's what we have to provide them in a different form, like L-Dopa. So the dopamine is not transportable, but if you have the L-Dopa, can transport into the brain. So you provide a substrate, then the brain there are some enzymes that can convert into dopamine.
I don't know if I'm getting the name wrong, the chemical name, but is L-Dopa, does that mean there's an R-Dopa or an S-Dopa? Are there other molecules that have chirality?
Yes, so the chirality is there, yes. L-Dopa is the one that most of the amino acids in our body, that L-Dopa is the one that levodopa So it's also called Cinemat, the brand name. Yeah, L-Dopa is the right form that needs for the brain to make a dopamine neurotransmitter.
But does the body produce a mixture of different kinds of dopa, or does it only produce L-Dopa?
Mostly L-Dopa, but some other ones, there may be some, they are dopas and things, but it's not that biologically, active amino acids that, incorporated into the proteins are making some metabolites that are essential for, the receptor stimulation.
Well, do people know if it's necessary to have a little bit of other kinds of dopa with L-Dopa to make it function properly, or perhaps the other kinds of dopa, perhaps they're necessary?
So they do have some, dopamine analogs, and there is a different form of the dopas, and dopa metabolites can stimulate various receptor or these subreceptors, but they're not as efficient as the signaling of the dopamine transporters that required for, execution of movements.
Okay, so having bacteria produce L-Dopa, has that been done in mice, or is it just in the petri dish for now? Like how far along?
No, we have done mice, even we have gone to the dog models. So the dog, it works really well. I think very at the late stage of our preclinical. I think we're trying to get into the clinical trials.
Oh, when will there be clinical trials in humans, do you think?
So we are thinking at least the next couple of years, at least we have to launch the phase 1, phase 2 studies. That's our goal to get there. So we are on the right track to get that going.
Any other promising treatments that you're looking at in addition?
Any other promising treatment other than the probiotic?
Right, in addition to it, yes.
Yes, yeah. So we have some additional, based on our mechanistic studies. There are mitochondrial dysfunction. We have identified with the mitochondrial stress. When the mitochondria gets stressed, the aging is a part of the stress response to the body. They activate specific signaling pathway that when you increase in the reactive oxygen species, the oxidative stress triggers a signaling mechanism that activates a kinase that we have killed this dopaminergic neuron. The dopaminergic neurons have this kinase, very high concentrations. So this aberrant activation of this mitochondrial stress response activates the kinase and kills the neuron. So we are in the process of making some small molecules and see whether we can block that activation of the kinase so that the cells can be saved. And the other one is we also identify another compensatory response during early stages of stress. There are survival signaling pathways that seem to protect the neurons against stress. So we are trying to identify some agonists or activators of that signaling pathway so that the cells can compensate when there is increased stress response. And so those are the two major ones we are trying to understand in the mitochondrial function. We also testing few anti-inflammatory agents that have a potential for, again, understanding signaling pathway, receptor biology, and things like that type of nature. So our group is looking at anti-inflammatory or the mitochondrial stress response modulators as a potential disease-modifying drug that can possibly develop as a drug.
Okay, well, very good. What's the best way for people to find out more about your research and to look into, in general, what's going on with Parkinson's research? What do you recommend?
Yes, one is the general public. Then you can go to the website and look for UGA and with my name, and there is some publications and things like that. We are in the process of developing some website. I just moved to University of Georgia just about 6 months ago, and we also have a center. We are building a new center for neurodegeneration. In the process of also recruiting additional faculty, 4 to 5 more faculty for our center, and we are building so that stage we are, new center that's coming up, and that will have a lot more news and upcoming news and what's going on in the research. So there will be a lot more stuff that they can look from our website. And of course, the scientists, they can look for our papers and what about technologies and those type of things.
Okay. Well, very good. Well, thank you so much for coming on the podcast. I appreciate it. I don't know, again, a lot about Parkinson's, but learning through these interviews. So thank you for your work, and hope listeners can benefit from what you said.
Yes, absolutely. I think ultimately patients need to benefit and make sure their quality of life can be improved. That's the ultimate goal. Thanks,
Excellent.
Rich.
Do you struggle with concentration? Have you ever thought of your brain health long-term? Bowmar Nutrition is revolutionizing the nootropic and cognitive health industry with sharp nootropic powder and patent-pending bright daily capsules, powered by NeuroBloom. If you struggle with focusing, think of Sharp as brain food that supports concentration. Sharp works with your natural brain chemistry to provide a heightened sense of well-being that can delay cognitive decline and also increase mood. Bowmar Sharp tastes amazing and comes in many different flavors, available in caffeinated and non-caffeinated versions. While Sharp is a short-term aid in cognitive health, think of Bright Daily Capsules as a way to improve overall brain health and prevent cognitive decline long-term. As we age, so does our brain. Supplementing with Bright has the potential to delay this aging process and helps your brain function optimally. Stay ahead of the curve and order yours today at bowmarnutrition.com and save $5 off with code GENIUS5.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.